I'm Prakul Agarwal. I'm a senior product manager for machine learning at MongoDB. And today I'm going to talk about modern generative AI application stack and building with MongoDB and Microsoft. So just to get started off with on what we are seeing as some of the current state of generative AI applications. There is a lot of the semantic text search powering all kinds of surface area. So in this example, we're just going over something like if you had a movie data set and you wanted to search for a certain kind of movie, but you don't exactly know the exact description or type of it, and you wanted to have a more natural language search. So something like imaginary characters from outer space at war, and with like these generative AI applications, like you can actually do that based on natural language understanding. Similarly, if you had image data set which is not labeled with text, you can build those powerful experiences. In this example, Airbnb data set, where we are just searching with houses with swimming pool, and this is information that's not in text but extracted from images using AI models. As well as the most quintessential example of Q&A with using RAG like paradigm. So RAG stands for Retrieval Augment Generation. We'll talk a little bit about it, but this is one of the most fundamental patterns that we are seeing that's powering all kinds of Q&A, conversational experiences, Copilot-like experiences. But essentially, as a motivating example, there for a query like which is you would ask something like a ChatGPT, right? Like and it's a newer query than when it was the underlying model was trained. In this case, we're asking a question about GPT-4 model. And for those of you who are aware, know that this is one of the more recent models from OpenAI. The response from ChatGPT, which is we'll get something like, okay, I have not been trained on this. I do not know what the answer to that question is. So this answer for GPT-4 and its capabilities is something that's available in a PDF, which is a technical PDF document which came from OpenAI after ChatGPT's underlying model was trained. And on the right, you can see using RAG paradigm and having that PDF, that proprietary data stored in vector database, we were able to get a pointed specific answer to whatever question that we were asking. So at a very high level, generative AI workflow for application involves query to a large language model, and you basically get a response back, right? And these large language models can be from OpenAI, can be from Hugging Face, but with essentially when you're using RAG, we intercept the query, pass it to a vector database, and augment that response of the user's query with the response from the database on what is similar to it. And with that, we are able to build a lot of powerful applications. So there is few questions about what does this modern stack look like, right? So starting from the very bottom, we focus on the foundational generative models. And for this category is basically the brain of the generative AI applications. This is followed by some of the model hosting or serving platforms. This is the AI infrastructure, which is able to instrument this brain and distribute it. This is followed by the data pre-processing, right? You have different data sources. How do you put it in a format that the generative AI stack can understand? Followed by the long-term memory for LLMs. This is the type of long-term controlled memory that can power. So the short-term memory is essentially the parametric knowledge of the models with which it's been trained, and this is the non-parametric outside memory. Followed by that is this LLM app framework, which essentially is something that puts together all these different components. Followed by LLM observability and evals. This is where we make sure that our generative AI applications are actually working as expected, have the necessary quality that we would require from a reliable application. So just to deep dive on that, on what a popular stack that we see, powered by Microsoft and MongoDB. So in this stack, we will focus on 3 core components that are required in any generative AI application: the foundational models, the model serving platform, and the long-term memory, the vector databases powered by MongoDB, and the LLM app orchestration powered by Microsoft Semantic Kernel. So let's dive deep into that. What does long-term memory for LLMs mean? As we talked previously in the example, there is a requirement for a vector database which powers these RAG-like applications that can augment large language models understood memory. Right. So for MongoDB, we have been working on vector search for a while. It was in private preview, got into for almost 2 years, got into GA last year. But essentially it simplifies the application stack with integrated architecture with your operational database as well as your vector database being in the same offering. So the use cases that it power for vector search are the semantic text search, image search, retrieval augmented generation, the Q&A that we talked about, recommendation and relevance, as well as anomaly detection being some of the few stereotypical use cases. So what vector search does is that allows you to build intelligent applications powered by semantic search and generative AI over any type of data. So this could range from text, images, video, audio, etc. With this, you're able to store your vector embeddings, right next to your source data and metadata. So practitioners among you know vector embeddings are generated, these array of floats, which are generated by a large language model, embedding model, which is a new type of data, right, like than what we used to store in databases, and that's what vector database allow you to do. One big thing, like again practitioners would know, if you had separate stores for your vector store as well as your operational store, you would require to keep things in sync as you insert new documents, as you update existing document, right? So with MongoDB vector search, it's an integrated approach. Thirdly, we are able to optimize the resource consumption, improve performance with something called vector search nodes that we'll talk about in a bit. Essentially, you are getting this operational, you're removing all the operational heavy lifting with a battle-tested Atlas platform, which is fully managed. So just to get into this, right, like, so one piece that's a big differentiator is for powering your generative AI applications with a vector search, you can have 2 separate stores as is shown in the approach on the top. This would require essentially having 2 separate query languages, and you would require some kind of an ETL integration pattern. So that's what is referred to as, like, bolt-on vector databases. The second approach that's outlined on the bottom is this having your databases integrated with this vector capability in a very native like format. So this essentially what that, like, MongoDB allows you to have your vector database, your transactional database, and your full text search in a single platform. The second piece that essential in this category is the MongoDB document model that allows you for easy modeling across data types, including vector embeddings. So when we're thinking of vector embeddings, it's kind of in conjunction with other pieces, right? Like that, how you model your data has a big impact on what you're able to do with it downstream. So we'll talk a little bit about the applications of what this flexibility allows you for, right, in terms of improving your retrieval performance. The third thing is the rich filtering. So we have composable queries which allow for combining vector search with other types of queries. So a few examples here. You can combine it with aggregations to say, find me all the images that are similar to one image, but group them by the photographer ID. Secondly, you can do filtering with metadata. Just help me find content matching users query, but only the content published in the last 3 months. right? So with semantic query is not necessarily great with dealing with dates and ranges, where a traditional query would work. Thirdly, combining things with geospatial search. Recommend me restaurants that match my taste, but only 10 miles from my current location. So these are also the various examples that you can put together with rich filtering capabilities. And thirdly, it's allows you for independent scaling. So on Azure, you can start off with an Atlas node, which contains transactional data and your vector search on single node. With one click, you can deploy these search nodes where you will have your MongoDB node and separate it from your dedicated search nodes. So these are essentially different kinds of work profiles, and you can have dedicated infrastructure that's specialized for these, while retaining the benefits of integrated nature, not requiring any ETL, having a single query languages, and being able to scale these independently. So these dedicated search nodes can be scaled all the way from 2 nodes to 32 nodes. So these are being rolled out to Azure Cloud and are not completely available yet. So on that, how does this capability help you with performing the stereotypical generative AI application, right, which is your retrieval augmented generation? So on this screen, we're showing how does retrieval augmented generation flow typically works, right? On the left top, you start off with your private knowledge sources, you put it through this indexing process, and you put it into a retrieval store. And this, when a user does a query, when it provides a no context is a query, it is passed through a pre-retrieval process, put into this retrieval store, and you're able to put it into prompt LLM and get to a particular output. So two-step process, but essentially retrieval is one big place where your accuracy of how well your generative application like RAG applications are performing. So with MongoDB Atlas, your retrieval essentially have multiple forms and shapes. Start off with a basic vector search. I trade that with metadata pre-filtering. Add on to that vector search with post-filtering capabilities. Combine that or use an isolation pure full text search, which is typically powered by this algorithm called 𝗦𝗽𝗲𝗀𝗏, or combined various type of searches using hybrid search. So to see what this means, right, just vector search with pre-filtering. So on that movie data set, semantic query, if we had this various queries, we wanted to search for just give me movies which are comedy but exist between 1980 and 1990 but have imaginary characters. So a user query like this with pre-filtering would essentially be a two-stage process, right, which in a MQL MongoDB query language stage happens in a single pipeline, giving you very accurate results, right? So there is also the possibility of post-filtering, where you would do a vector query on your semantic query search, get the results which will be sorted by your vector score, do a filtering based on the date, and get your final result. In this case, you will realize we do not get the requisite two queries because of how the pre-filtering and post-filtering behave differently. So the third example is being able to use hybrid search, right? So hybrid search, in this case, we essentially for a single query, we do a vector query using Atlas vector search, using an embedding model, as well as do a full text search query, combine them, fuse them together in MQL by an algorithm like a reciprocal rank fusion, giving us this data set which is differently ordered than what a pure vector query would happen. The benefits of this is that in some out of the domain languages, especially like healthcare or things like legal, where there's a lot of jargon, a lot of tribal knowledge, the embedding model that you're using underlying may not be trained on the data set where your text search will work well. So essentially being able to tune between what and where, how you do your retrieval can be super powerful, as we see with our customers. The second component that we talked about in this generative AI stack is that of foundational models. At this point, I believe most of you are aware of what these foundational models are. So these are large language models trained on wide swaths of data, can be used for a wide range of downstream applications. A lot of them have multimodal capabilities. They can deal with text, they can deal with images, they can also deal with videos and audios. But like in an enterprise generative AI setup, right, we want to talk about how these foundational models play out, right? What would that evaluation criteria be as you're putting together this application? So the one big problem that we see is like, with enterprises is you require your AI models to be used safely. This is performing inferences on critical data, and there are various considerations like, is my data being used for model training, right? Whatever I'm saying to a foundational model. Can I choose which data center serves my request? Because I have certain data residency requirements to be in compliant with local laws. Can I have access control to what model, to what particular database, who has access to what? Can I use more advanced authentication mechanisms like private link? So this is where foundational models, like, you cannot use any foundational model, right? Like, so even with OpenAI, there is ability to use OpenAI directly, or you can use OpenAI on Azure. So using something with Azure OpenAI, these capabilities that are super table stakes for enterprises are something that's available off the shelf. And with MongoDB's fine-tuned settings, you are able to ensure all the requirements for being able to use foundational models are met. So you make sure data is not used for model training. You ensure that you choose between multiple data centers that serves my request. You ensure that there is fine-grained access control on who gets control, who gets to see data, who gets access to what model, etc. And you can use advanced authentication mechanisms like private link. So that's what having these battle-tested services can bring for you. Now, we talked about a bunch of steps in generative AI applications, how you would do it. We talked about vector databases, we talked about foundational models. But now, how do you put all of these different components together, right? That's where the third piece of our stack, which is the LLM app orchestration, comes in. Just a motivation example of this is like powerful AI applications require both memory and models. So these powerful AI applications are things like your Copilot's experiences, Q&A chat that we discussed. You require an orchestration layer that can securely, scalably, and keeping up with the latest advances, allow you to access your foundation models and your AI serving infrastructure. So this is where we want to talk about Microsoft Semantic Kernel. So Semantic Kernel is an open source SDK from Microsoft that allows for putting together models and memory, and MongoDB is an integrated part of the Semantic Kernel. So the steps that we talked previously on how you would put together a RAG-like application where you need to combine a embedding model, vector database, proprietary knowledge, we'll just walk you through how easy it is to build something like that with Microsoft Semantic Kernel and MongoDB. So to do that, we start off with initializing our SDK. So Semantic Kernel is in multiple languages. MongoDB is integrated in the C# and Python version. So these examples we just walked through is Python, but we have good tutorials, examples for how you would do that in C# as well. So start off with initializing your MongoDB Atlas memory store. And as you can see, this is one of the connectors for memory in Semantic Kernel. You follow that up with registering your memory store, follow that up with initializing your embedding generation service, which is your OpenAI. And once you've done that, you just go ahead and start saving information. In this case, we inserted a sample data with certain ID. And what it does is essentially you get access to that data into your MongoDB, and it's been generated with the embeddings from a large language model, as well as it has some other metadata that helps you do it. So in this simple walkthrough, you can see the power of Microsoft Semantic Kernel, Microsoft Azure OpenAI, and MongoDB in being able to effectively bring these powerful generative AI applications to life easily and faster. With that, thank you so much.